All right, welcome to 4.2 land. Good to have you. Go ahead and share my screen so you have your notes out, ready to roll here. This is gonna be awesome. Okay, so go ahead and do the warm up. First, I want you to write an equation in slope-intercept form with the given slope and y-intercept. Think about, hopefully you remember what slope-intercept form is. If you don't, you should. Yeah, it's y equals mx plus b. So what's the form? You gotcha. Y equals negative 3x plus 6. Okay, and now a little literal equations review. Solve the formula for the indicated variable. Solve for r. Well, hopefully you just added c to both sides and had p plus c equals r. All right, awesome. Okay, our learning target here is that you will be able to write an equation of a line when you are not given the slope and a point on the line, or that you will, that you will not. You already know how not to do it. You're going to learn how to do it. To be able to write an equation when you're given the slope and a point that is not the y-intercept. Up till now, you've always been given the y-intercept. And we use slope-intercept form, right? Y equals mx plus b. Now, as long as you're given a slope or can figure out the slope and any point, you're going to be good to go. Okay, so you can work with your imaginary partner again. The point x sub 1, y sub 1 is a given point on a non-vertical line, okay? The point x comma y is any other point on that line, okay? So we have 2 points, okay? Write an equation that represents the slope of the line, okay? Well, we know that. That's change in y's over change in x's, right? So then rewrite the equation by multiplying each side of the difference of the x coordinates to obtain the point slope form of a linear equation. So new form. So remember, we've had standard form, ax plus by equals c. We've had slope-intercept form, y equals mx plus b. And here we're going to get point slope form. Okay, so to figure out what the slope is, remember it's the change in the y's, the difference of the y's over the difference in the x's. So one way would be to go y minus y sub 1 over x minus x sub 1, okay? And then what we're going to do basically is we're going to solve for y minus y sub 1. So we want to just get this by itself. So what would we do? We would do exactly what we set up here, which is to multiply each side by the difference of the x coordinates. So that would look like that. We're multiplying, right? So what happens here? This is like it's over 1, right? So it's in the numerator. It can cancel with this denominator. And then what do we rewrite it? And we can flip it over. And this, my friends, right here, y minus y sub 1 equals m times the quantity x minus x sub 1 is what we call point slope form, okay? So in other words, if I said write something in point slope form, if you knew what the slope was and you had any point that's on the line, you would just plug the coordinate, the x coordinate here, the y coordinate in here, and you'd be done. And that's what we're going to get into. Okay, so for 4 months, you have saved $25 per month. You now have $175 in your savings account. Congratulations, that's awesome. Saving money is so important. If you take my Money Matters class, you'll learn all about that if you haven't already. Use your result from the previous exercise to write an equation that represents the balance A after T months. Okay, and I've put y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, so we got 25 here, right? 175 minus 75, because what's the coordinates of this point right here? Isn't it 0, comma, and it looks like it's about 75, right? So the difference of the y's, 175 minus 75 is 100. 4 minus 0 is the difference of the x coordinates is 4, and that reduces to 25, okay? So we have the slope. We now have a slope. Do we have a point? You betcha. So we can write it as, they're using A, right? Because A is what our y coordinate is here, right? Our vertical axis. Minus 175 equals the slope, m, and then t, right? Instead of using x's, they're using t for time, minus 4. And if we wanted to put that into slope-intercept form, we could do that. Okay. All right. So here we go. Point slope form. As I said, y minus y sub 1 equals m times quantity x minus x sub 1. Okay. M's a slope. You plug in the coordinates x sub 1, y sub 1 for any point that's on the line. That's what's so great about this. Any point you want does not have to be the y-intercept. Could you plug in the y-intercept to that? You certainly could. Could you plug in the x-intercept? Yeah. Can you plug in any point that's on the line? Yes. Okay. So write an equation in point slope form of the line that passes through the point -8, 3 and is a slope of 1/4. This is as easy as literally just plugging the three things in. Slope is m, it goes right in there, 1/4. Okay. The -8 goes in for x sub 1. Be careful, minus the negative, right? That's what the formula is. The 3 goes in for y sub 1. Okay. And that's it. If I said put it in point slope like this one says, you're done right there. Now I might say from there and then transform it into slope intercept form or put it into standard form, and you would just have to manipulate the equation around to do that. Okay, so here we're going to do a few more of these. So why don't you try this one on your own? You're given a point, you're given a slope. I've put slope intercept up here again for you. Give it a try. Okay, I'm back. So hopefully you literally just plugged in, and then probably want to simplify it, right? To minus a negative. We don't like to write it that way. We want to write it as plus. Okay, and how about for this one? Yeah, there you have it. And you could put y equals, right? But this technically is point slope form. Okay. So now we're going to write an equation in slope intercept form of the line shown. Okay, now here's the issue here. We don't know what the y-intercept is. We could figure out the slope, right? But we don't know what the y-intercept is. But we do have points, right? In fact, we have 2 points here. So can we figure out the slope? Sure. We could either do the subtraction of, -2 minus 2 over 3 minus 1, so the change in the y's over the change in the x's. Or we could, since it's graph for us, we could count up 4 and then -2, so that would give us a slope of -2. Either way, you can do it any way you want. And then once we have the slope and we have points, we just have to plug into point slope form. Okay, and then we're gonna have to put in a slope intercept on this one. But let me ask you, do you think it matters which point you plug in? No. Just like, as I mentioned before with standard form, that might be your formal name, your full name. Like for me, Michael Robert Kalin. But there's I have lots of other names, right? Like nicknames, right? Mike or Mr. K or Coach K or whatever, right? So watch here, I'll plug in this, right? So 3 goes in for x sub 1. -2 goes in for y sub 1. My slope is -2, that goes in for m, okay? And then I'm gonna have to clean that up, right? Now I'm gonna have to get this, because I wanna get the slope intercept form for this one. Gotta follow the instructions. So obviously you're gonna clean up the left side to y plus 2, and then you're gonna need to distribute. So, I didn't do that step, I guess. Here I did, right? And then what's the last step to get into y equals mx plus b form, slope intercept form? We need to subtract 2, and we get y equals -2x plus 4, okay? Notice, though, that if we use the other point and we plugged in 2 for y sub 1, 1 for x sub 1, and again, the same -2 for the slope, this point slope is different than this one, but that's okay. There's an infinite number of points in this line, so there's an infinite number of point slopes. But when I distribute and move over the -2 to get y by itself, I get the same slope intercept form, because there's only one y-intercept and there's only one slope for a given line. So this is going to be the same. So it doesn't matter. Do you have to do both? No. Would that be a way of checking? Sure. Could you, if you wanted to, use this point here and then plug in 1, 2 here to make sure you did it correctly? Absolutely, because this is a solution to the equation too, right? So if I plug in 1 and I plug in a 2 here, I get 2 equals, -2 times 1 is -2 plus 4 is 2. 2 equals 2. Check, check. Okay. Huh. Now remember, with all this stuff, we gotta have a point and we gotta have a slope. We can't write it in point slope without that, okay? So, do they give us any points here? F of 4 equals -2. F of 8 equals 4. What in the world does that mean? They must have given us something. Oh yeah, F of 4 equals -2 means that the output of that function is -2 when the input is 4. Oh yeah, and the input is the x coordinate. Yeah. So I have 4, -2 as a point, and I want you to think about what this point would be. If the input is 8, the output of the function is 4. Yeah, 8, 4. Hey, I have 2 points. So now I have a point. In fact, I got 2 of them. Can I figure out the slope? Of course you can. Use the change in the y's over the change in the x formulas. So one way, 4 minus -2 over 8 minus 4 gets us 6 over 4, which reduces to 3 over 2. And by the way, if we'd done it the other way, -2 minus 4 would have been -6. 4 minus 8 would have been -4. Isn't -6 over -4 the same thing as 6 over 4, which is 3 over 2? It sure is. So now I have my slope. I just have to pick a point, pick either one. You don't need to do both, and go for it. I'm going to do both. So no matter which one you pick, you'll see the right thing. So here is where I used the 4 comma -2. Here is where I used the 8 comma 4. And notice that when I linear function, what are they talking about? Slope-intercept form. Yeah, that means slope-intercept form. So f of x equals 3 over 2x minus 8. Okay, and notice how I used y here because that's what the point slope form is. We wanted to go back to f of x just because it's called a linear function f. If you put y, I'm probably not going to take off major points for that or any points probably. Okay. All right. So here we go. Same instruction up top, except you're going to put it in slope-intercept form. I guess that is the same. And here I've given you just 2 points. And what I'm going to use when I plug in a point slope is a 3 comma 10. So what do you have to do first? Think about it. Well, you got a point, but you got 2 points. But do you have the slope yet? No, but can you figure it out? Yes. So do that. Okay. So hopefully you got 3 for your slope, right? Change in the y's over the change in the x's, rise over run. And then I used, like I said, 310. So I plugged in 310. And we had to get it to slope-intercept form, y equals mx plus b. So obviously I want to distribute and then add 10 to both sides. And I get 3x plus 1. And again, you want to make sure you're doing it right. So check it by using the other point, 1 comma 4. If I plug a 1 in there, I get 3 times 1 is 3, plus 1 is 4. And I'm going to be plugging a 4 in for y. 4 equals 4. Check, check. Okay, now we're going to write a linear function g with the values g of 2 equals 3 and g of 6 equals 5. Okay, so remember, you got to have a point and you got to have a slope. Well, they didn't give us anything here, except they kind of did, right? They gave us enough information to figure out 2 of the points for the function. And then once we have 2 of the points, we can figure out the slope. Good. So g of 2 equals 3 means when x is 2, or the input is 2, the output, the y, the function, is 3. Okay? And then if it's 6, you get a 5. Okay. So figure out your slope. Okay, 1/2. I'm plugging in 2, 3. So if you want to do it the same as me, great. If you want to plug in 6, 5 and get to the same place, totally fine. So go ahead and do that. Again, your friendly teacher has put the formula here. Do you think you need to memorize that? Of course you do. Okay, so plugged in. And now we're going to get it. So it's a linear function, which again means slope-intercept form. So I distributed, and then I'm going to add 3 and just put g of x instead of y. Okay. And let's check using the other point, 6, 5. Okay. So if I put a 5 in here, right? So I'm going to have 5 equals, what's half of 6? 3 plus 2. Are those two sides equal? Does that balance? Does that mean that this point made that equation true? It sure did. We did it right. Awesome. Check, check. All right. Student council is ordering a customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. It's like an eagle, like you put your hand in it. It's like you're flying an eagle around. All right, the table shows the cost of ordering different numbers of foam hands. Can the situation be modeled by a linear equation? Well, that would mean that it would need to be what? The graph would have to be a line, right? And a line would mean that we'd have to have what kind of slope? Or we would have to have a slope, right? A constant rate of change. So what we need to do is figure out whether we have a constant rate of change. Up 2, up 12, up 2, up 12, up 2, up 12, up 2, up 12. By the way, so what's the slope? Well, remember, this is the vertical, right? This is the dependent variable. This is the independent variable. So this is the y, this is the x. So what was the change here? 12 over 2. What's 12 over 2 reduced to? 6. So the slope is 6. And by the way, notice that if I went 4 to 12, that's an increase of 8. And that's 32 or 84, excuse me, 82 minus 34, which is what? 48. What's 48 divided by 8? 6. So it doesn't matter what 2 points you use, but we did want to check to make sure that it was a constant rate of change. So, yeah, right? Okay. So, and by the way, I didn't mention this, but a linear model is just a linear function that involves like a real life situation. Okay, so we know the slope. Do we have points? Yeah, we got 5 different points here. Let's pick one. I'm going to guess that I either used the 434 or the 1070. Let's see which one I used. Okay, I used the 434. Oh yeah, because I need to figure out this. Well, I did the slope already. We already talked about that. There's a slope. Let's see which point I used to plug into point slope form. Okay, I used the 4 and the 34. I figured I probably did. Although the 10 and the 70 might make the numbers a little bit easier when I have to distribute and add and subtract, but whatever. All right, and we have to put this in what linear model is a linear function. Linear function means slope-intercept form, y equals mx plus b. So hopefully you distributed and then added 34, and you get y equals 6x plus 10. Okay, so if we wanted to write it as a linear model or linear function, the cost of n number of foam hands, if you used x and y, and g of x or whatever, it's totally fine, doesn't matter. All right, and let's try one more here. You pay an installation fee and a monthly fee for internet service, okay? So in other words, when they come to install your Wi-Fi or your internet, your router, you're paying a fee for them to come. And then you have to pay for monthly service. That's how this works. Although sometimes you can get installation fee waived if you're switching companies and stuff like that. Okay, the table shows the total cost for different months, numbers of months. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the total cost as a function of the number of months. Okay, so the first question is, can the situation be modeled by a linear equation? Well, let's see. We go up 3 and up 3. What's this increase? 302, 176. Oh my gosh, to 300, that's what? 124, so it's 126. So 3, 126, 3, 126, 3, 126. So yes, it can. Okay, which means that it has a constant rate of change, which means it has a slope. Okay, so figure out the slope. Lots of points there, right? I've kind of given you the numbers, so we already kind of know that it's going to be, if I use 302, 6 comma 302 and 3, 176, change in the y's over the change in the x's. 126 over 3 is 42. Okay, and then I used this point. I could have used any of those 4 points that are there. Plugged into point slope. And then distributed and moved over to 176. And there we have it. So what does this tell us, by the way? What does that 50 tell us? What do you think that is? I'm hoping you said it's the one-time installation fee, right? Because you only install your Wi-Fi once with a certain provider. So that would be the installation fee. What does the 42 represent? The monthly fee, exactly. Okay, terrific. Well, I hope that helps. And we've now learned standard form, we've learned slope intercept form, and now we've got point slope in our toolkit. So I hope you got that. Ask questions, come see me at contact time, happy to help. And just like that, we're halfway through chapter 4. I'll see you later.